All right, in goal 5.4, we are solving rational equations. So we've simplified them, we've multiplied them, divided them. In our last lesson, we added and subtracted them. This time we're going to be solving a rational equation. So we'll have an equal sign. You will see some similarities to what we did with adding and subtracting with the solving. So step number 1, find the least common denominator. To do that, you might need to factor, just like we did when we added and subtracted. You're going to multiply every term of the equation by the LCD. What's going to happen then in step 3 is we will be able to cancel all of the denominators out. We will be able to cancel like factors from each term of the equation. We'll multiply what's left, and that will give us an equation that we should know how to solve based on things we have done this year. So I'm going to go through it with those 5 steps, and then I am going to show you a little shortcut that you could use that's kind of more like I taught you the adding and subtracting. So question number 1. We have 2 denominators with integer denominators, so we have to create a common multiple for those. So 2 and 3, the least common multiple would be 6. And then again, if I look at all my denominators, I also need that x. So my least common denominator is 6x. So then I take every term of the equation times the common denominator. On the first equation, first term, x will cancel with the x up there, leaving me 5 times 6 up top, which gives me 30, minus, on the second term, 2 cancels, divides into 6 3 times, leaving me 1 times 3x, or 3x, equals, and then 3 cancels, divides into 6 2 times, leaving me 1 times 2x, or 2x. So that's the new part. Those are the first 4 steps. Once we got that finished, then we get an equation that we should know how to solve, should being the key word there, but should know how to solve. I've got to get x alone, got to isolate my x, so I'm going to add 3x to the right. So my 30 comes down, cancels out, 2 and 3 is 5x, and then divide by 5. And x equals 6. All right, question number 2. We find our LCD just like we did when we were adding and subtracting. So if I work from the left to the right, I'm going to start by I need an x plus 2. I jump over to the next fraction, I need an x minus 1. So I multiply each term of the equation by that LCD. Excuse me. So on the first term, my x plus 2 cancels, and I'm left with 3 times x minus 1. So I distribute 3 times x, 3x, 3 times minus 1, minus 3. And on the second term, x minus 1's cancel, and I'll distribute 2. 2 times x, 2x, 2 times 2, positive 4. And then again, I get an equation that I should know how to solve. Most of the time I like x's on the left, so I'm going to subtract my 2x. It's a positive, which means I'm going to subtract it. So 3 minus 2 leaves me 1x, minus 3 comes down, equals, cancels out there, 4. And then I'm going to add 3 to both sides. To get x alone, and x equals 7. right, next example. Forming my LCD. Again, starting on the left side, I need an x plus 3. And I need, jumping to the second fraction, that plain x. So my LCD being x times the quantity x plus 3. So I multiply by the whole thing. On the first term, my x plus 3's cancel out, and I'm left with 2 times x, or 2x. On the right side of equals, on the next term, my x's cancel, the plain x, and then I'll distribute and get 5x plus 15. And again, that's my new part. Then I'll solve the equation. So subtract your 5x. 2 minus 5, negative 3, x cancels, 15, and then divide by negative 3. And x equals negative 5. Okay, I'm going to show you the shortcut on this next question, and then you can opt to use it or not. I'm going to keep doing it the regular way, but the shortcut makes it less cluttery, it makes it less messy, and a little bit easier to read. And if you get it and you understand it, I would recommend using it, okay? So I'm going to show it to you on this one question, then you can choose. Okay, so I formed my LCD. So starting on the left, I need that x plus 2. And then going to the next term, I need that 4. So instead of writing the entire LCD, we're going to do like we did when we added and subtracted, and we're going to compare. And we're going to say, okay, this denominator compared to the LCD is missing the 4. So I'm just going to write the 4 there. This denominator compared to the LCD is missing the x plus 2. So I'm only going to write the x plus 2 there. What you have to know when you use the shortcut though, because you're not visibly canceling out the denominators, that when you use the shortcut, these are gone. Denominators are gone when you use the shortcut. There's still no fraction left. So then I'll distribute this 4. So I have 4 times x. Let's go to my black to my blue. 4 times x, 4 times negative 7 equals 1 times x and 1 times 2. And I'll finish this out and then we'll talk about that shortcut again. Okay, so I'm going to solve. So I'm going to subtract my x. 4 minus 1 is 3x. Minus 28 equals 2. And then we're going to add 28. So I have 3x cancels equals 30. And then divide by 3. And x equals 10. Now, again, with the shortcut, you're simply not writing the entire LCD. You're only writing basically what would be left after I cancel. So let's go back and look at this one. So look at this one. I had an x plus 3, which means all I needed was the x. So that's what was left after I marked off the x plus 3's. Likewise over here, if I compared this denominator to my LCD, I needed the x plus 3. So if I didn't write the x there, they canceled out here. If I used the shortcut, I wouldn't have written it there. So what you're not writing is what would be canceling out anyway. So again, the shortcut is going to be your choice. If you want to do it, great. If not, that's up to you. It does make for less clutter. All right, next example. LCD, working from the left to the right. I need a 3, I need an x. I jump over here, I need an x, which I already wrote, so don't write it again. So I write my common denominator by every term. If I were using the shortcut, I wouldn't write anything next to that 5. I would only write the 3 next to that 3, and I would write everything on that one because that has a no denominator in it. Okay, so my first term, 3's cancel, x's cancel, and I have left just my 5, plus, on the second one, x's cancel, and I have left 9, equals 12x. So nothing canceled on that last term because there was no denominator. And then we solve. 5 plus 9, 14, equals 12x. You can get x alone, so divide by 12, and x equals 7 over 6. So all I did was reduce this fraction and divide by 2 into both of those. So that's where my 7/6 came from. Okay, these next two examples are a little bit different. Still something we've done before once we get our equation, but going to be a little different. All right, least common denominator is x because it's the only denominator. This fraction, or this equation, I'm sorry, has one denominator. It's x. So everything gets multiplied by x. Nothing cancels on this first one. If you think it might be helpful for you to write this as x over 1, so you understand that there's no denominator other than the understood one, then do that. If you don't need it, don't do it. So x times x, x squared. Plus, in the second one, x cancels with x, leaving me just that 4. And on the last one, negative 5 times x is negative 5x. Now, I said this one was different. The reason it's different is because I'm ending up with an exponent in the question, in the equation. And when you have an equation with an exponent in it, you have to get it equal to 0 and factor. That almost looks like 2 instead of 0. So get it equal to 0 and factor. So we've done this. It's been a little while. So we're going to move that 5x over. So that means we're going to plus 5x. The order that you write this in, really important. So the x squared comes first, then the 5x, then the 4. So it's always the x squared term, then the x term, then the constant term. And we factor. So x squared, x times x, plus at the end is 1 of each sign, and then my factors of 4, which will also give me 5 in the middle, 4 times 1. And then I get 2 solutions on all these. And if you can remember our shortcut, this is where we would change the sign. So we would say negative 4 over understood 1, or negative 4, and then negative 1 over understood 1, negative 1. So 2 solutions if you have an x squared in your equation. Okay, I want to do another one like that. The next one is similar. Just one little change, sign change. Okay, my LCD once again is x because it's the only denominator in the question. So x and x and x. So first term, x times x is x squared, minus x cancels with x, leaving me 63, equals 2 times x, 2x. So again, I need to get this equal to 0 and then factor. So I'm going to move my 2x over. So it's positive So I'll minus. And again, order is important. X squared, then the x, then the constant. And then I factor x squared, x times x, minus at the end, 1 of each sign. And then again, my my factors of 63, that then will also give me negative 2. It's going to be negative 9, positive 7. And then I get my 2 solutions. Again, I'm going to change the sign. So negative 7 over understood 1, negative 7, positive 9 over understood 1, positive 9. Okay, my last 3 examples are similar to each other, especially these next 2. All right, this denominator is factorable. If a denominator is factorable, you should always factor it first to create the LCD. So starting on the left, my LCD needs an x plus 1. It needs an x minus 1. Jumping to the next fraction, it needs an x plus 1, which we already wrote. So we do not write it again. So first fraction, if we're using the shortcut, you're not writing anything there because that denominator looks exactly like the LCD. But if we're doing it this way, they cancel out. So you can see it, there's nothing left to multiply by, and I just have the 3x plus 2. On the second one, my x plus 1's cancel, and I'll distribute 8 times x, 8x, 8 times negative 1, minus 8. And then I solve. So subtract the 8x, bringing it to the left. 3 minus 8, negative 5x. Bring your 2 to the right, so subtract 2. So negative 5x equals negative 10, and divide by negative 5. And x equals positive 2. So again, we had to factor that denominator first. Likewise, on this one. We're going to factor x times x, 2 times 2, plus minus. So creating the LCD, I need an x plus 2, starting on the left. I need x minus 2, moving to the right. I need x minus 2, which I already wrote, don't write it again. I need x plus 2, which I already wrote, so don't write it again. So let's use our shortcut just to show you that one more time. So this denominator, compared to the LCD, has everything. It looks exactly the same, so I don't write anything here. This denominator, compared to the LCD, is missing or needs the x plus 2. And on my third term, this denominator, compared to the LCD, needs or is missing the x minus 2. And again, keep in mind though that when you take the shortcut, the denominators are gone. So 2x plus 1 comes down. I'm going to distribute a positive 3. 3 times x, 3x, 3 times 2, positive 6. And on the right, I'm going to distribute 6. 6 times x, 6x, 6 times minus 2, minus 12. So on the left, I'll collect my like terms. So I have 5x plus 7, 2x and 3x, and then 1 and 6, equals 6x minus 12. Again, I like x on the left, So I'm going to subtract 6x. So 5 minus 6, negative 1x, plus 7 equals, those cancel, negative 12. Subtract 7 from both sides, negative 1x equals negative 19. And divide by negative 1, and x is positive 19. And then my last question. LCD, starting on the left, I need a plain x. I need a group or quantity x plus 4, plain x plus 4. Need plain x, which I wrote, so don't write it again. I'll go back to the long way, but use the shortcut if you want. So on the first term, x cancels with x. So plain x with plain x distribute, and I get 3 times x, 3x, 3 times 4, positive 12. X plus 4, 2 times x is 2x, and then x cancels with x, distributing I get 4x plus 16. 4 times x, 4 times 4. And then we solve. So collect your x's. 2 and 3 gives me 5x. Bring down that plus 12. Equals 4x plus 16. Subtract the 4x to bring it to the left. So I have 1x plus 12 equals, let's cancel, 16. And then last step, subtract 12, and x equals 4. So again, you can choose to do it the way where you multiply by the entire common denominator and cancel, or use the shortcut by multiplying by what you need and just knowing that there's no denominators left then. All right.